Here's a 1959 Silvertone 6 transistor 2202 transistor radio. It doesn't work. When I put power to it, there's absolutely no sound. Looking at the schematic, I can see why I'm not hearing anything in the output, because right there you've got a 30 microfarad electrolytic that feeds the speaker, and then in the driver transistor you've got a 50 microfarad in the emitter circuit, and then a coupling capacitor 10 microfarad from the volume control to the driver transistor. And there's also a 50 microfarad right across the power supply. And then there's another one, a 10 microfarad, that is in the AVG circuit. So the ones that would be most likely to make the circuitry go silent is the one that feeds the speaker, and the one that feeds the driver. If any of those went open, you wouldn't hear anything. And then if the 50 megahertz, 50 microfarad capacitor right down in the emitter circuit, that would just reduce the gain of the driver transistor. So I think what I'll do, since these are all very easy to get at, I will just replace them all. Compared to the Sony that I fixed earlier, this circuit board isn't as neat, but it's more rugged. It's got a more rugged looking ferrite rod, and it's got an actual open variable capacitor, which would make it easier to fix in case you got plates that are rubbing. And it's a lot more room in the circuit board to change electrolytics. These can easily be changed. If any of these transistors are gone, I have similar ones that I can replace it with, but right here you can see the electrolytics right there, there, and right here. Replace those and I'll probably hear something. Even if you got a transistor that is bad, I'll probably hear something. Also, I noticed there's another problem. Right down there, we've got a break in the circuit board. So I'm going to have to run a wire from here to here. It'll be easy to do. So that's what I'm going to do. Change all the electrolytics and fix that that broken trace on the circuit board. Rather than trying to fix that little bit of circuit board there, I'm just going to clip it off. Let's see if I can do this while I'm holding the camera. Yeah, it just flaked off. So I'll just put a wire down there and it'll stick on much better. There's the repaired connection, just by bypassing it with a wire. I thought I'd check one of the electrolytics. It should be 50 microfarads and it's 13.7 picofarads, so it's completely dried up. There's nothing left. Corrosion has taken its toll in this radio, so I'm going to have to clean that one there, clean that gap, and bridge it. There I've rebuilt the circuit traces and wired in the 250 megahertz electrolytics. The next one I'm going to have to remove is this 10 microfarad electrolytic. I'll have to remove it from the board and put the same bend in it so it doesn't get in the way of anything. There I replaced the third capacitor, 10 microfarads. That was the hardest one to replace. Now I'm going to replace this one and that one there. Electrolytics that are right in the middle of stacked up with other components like that, it's best just to twist them out, and then you have the pins that stick in the circuit board, and you can they're easier to find. So that's what I'm going to do with this one here. This one here I'm going to rock it out and cut it out. Amazingly, that capacitor just came out without any effort. The leads came out of the solder joints. So I think some of the problems with this might be that it's got bad solder joints and they're not holding on to the leads anymore. And one interesting thing about this is that this actually still is, it should be 30 microfarads, but it measures 41. The other three are completely dry. There's almost no measurement on the capacitance meter. I didn't have a 30 microfarad, so I put in a 47. And that won't make any difference because it's just passing a signal to the speaker. If anything, it'll give it a deeper sound. One thing that's very important when you're replacing electrolytics, make a note of the positive and negative. And those early electrolytic capacitors in early radios, the right hand, or not the right hand, but the positive was marked. In today's miniature electrolytics, axial, the negative is usually marked. So that's something to make note of. Here's two electrolytics. The original one, the 10 microfarad. It's got the positive terminal designated. And here's a modern 10 microfarad. It's the negative terminal that is designated. So that's something to make note of before you put in a new electrolytic. After replacing all the electrolytics, I put power to the radio and I don't get anything. So I checked the loudspeaker and it doesn't work. So I'm going to have to try another loudspeaker. But first I'll check with a scope and look at see if there's anything across the speaker, any waveform. I replaced the loudspeaker with one of the same size. Unfortunately, it doesn't have the little nut holder on the back. It's like this one here. It's exactly the same size, but it doesn't have this on it. I'm going to see if I can break this off, the old speaker that doesn't work, and stick it on there somehow, maybe with epoxy. But I'll worry about that once I get the radio working. Now, having replaced the speaker, I'm still not getting anything out. When I turn it on, I hear a click, that's it. I checked this transistor here. I checked to see, this is should see something coming out, some waveform coming out of this. And that is this transistor here. And I didn't see any waveforms coming out of there. And Also, I checked, I fed a 455 kilohertz signal into here, and I didn't hear anything coming out of the speaker. In addition, I checked where are we here? It's there. The detector diode. That's kind of weird. That's down here, right down there. You can see the detector diode down there, a little germanium. I checked that with a diode checker, and it checks high on one direction. It's a germanium diode, but it still checks high on one direction, but in the low resistance direction, it seems to be extra low. So I'm going to have to take it out and check it outside the circuit. So this is turning out to be very complicated. So I'm going to have to just start isolating sections and see why they aren't working. What I'll do is maybe start with this one and see why this isn't oscillating. Maybe the transistor's faulty. So I'll have to take it out and check it externally. I'm testing the transistor that I took out, the 2N194A, and the transistor tester just shows it as it's just seeing one junction as being working. So that transistor is no good. An interesting thing to note about this is that every single transistor in this 1959 radio is an NPN, which is very unusual for that time. Almost all transistor radios use PNP transistors. And when restoring a radio like this, finding a PNP or an NPN transistor from, that will be compatible with that 2N194 or any of the others would be very difficult. I'm looking through my stash of germanium transistors here, and I've come across a couple of 2SDs that check out okay. The only problem with 2SDs is that they are Japanese audio frequency transistors, and the gain bandwidth product might not be very high. It might just be a couple of hundred kilohertz. Then that wouldn't be suitable for use as a mixer. So I'm going to look for a 2SC, which is an NPN RF transistor. If not, I'll just have to check into the specs of these 2SDs and see what the highest frequency they can operate at. So I'll go through the rest of the stash to see if I have any 2SCs in there. I might luck out. I thought I was lucky. I found a 2SC, but it turned out to be silicon. Here I'm checking out some of the characteristics of the 2N1302 that I have, and it should have no problem working at 1 megahertz, as all you need in a AM radio. So that one is a definite possibility. One thing is it's got a very low gain though, 27, which is quite low for a transistor. I replaced the transistor that I had taken out with an NPN transistor, germanium, and it looks like there's no signal. I hooked it up to power and I don't see anything on any of the terminals. I don't see anything. I should see something on the collector, but I don't see any signal. So this could be due to the fact that I've got some wires that are not hooked up to the coils, or it could be that it's just a very low gain transistor and it's not suitable for that particular application, which is the most critical in the whole radio. The next gain, the IF transformer, or the IF amplifier, that just needs to be able to amplify at 455 kilohertz. And the others are just audio transistors, which are not really demanding. So that one I might have to try a number of different transistors before I find something that's suitable. I think I might have to, the 2SB probably won't work. It's too low frequency. And it looks like I'm going to have to go to a silicon transistor. Here I found a brand new, never before used NPN transistor, silicon. And it has a high gain, 347. So I'll give that a try and see what happens. I just clipped out the old transistor. I had it on, I had extended the leads anyway, so I just don't want to damage the circuit board lands. So if I put this in, I'm just going to wrap the wires around the ones that are in there, so I can take it out quickly. I put that transistor in and I'm having no luck either. I'm not seeing any waveforms whatsoever. I've had quite a time with this circuit here, trying to get it to oscillate. I've tried a number of different transistors. I've soldered them in. I found that this resistor here had gone to about 4,000 ohms, so I replaced it with the closest one I had, which was about a 33 kilo ohm. And I put a transistor socket in here so I could try in various transistors. And I have very few NPN germanium transistors. So I tried in a 2SD, which is an audio frequency, and it wouldn't oscillate. But I plugged into the transistor socket an NPN silicon, and it worked. So that's giving me nice oscillation. So here I'll show you. So here I've put in a transistor socket, and there's an NPN silicon transistor, and it's oscillating very nicely. As I turn the dial, I see it going up and down with the appropriate IF frequencies. So I'll just show you as I change it. Okay, there is the circuit. There's it's going from just over a megahertz right up to 2000 megahertz. So that's 455 kilohertz or thereabouts above the received frequency. So that seems to be working very well. So I'll put in that, I'll wire in that silicon transistor, and then I'll go to the next stage. The reason it wasn't oscillating was not only because the transistor that was blown, but also there's a problem with this. There's a little return here. Let's see if I can, that little capacitor there, and there's a little wire there. They weren't making contact on the circuit board. Right here, that's that capacitor, that's 0047, and this is the wire that connects with it. The connection was broken right there. So now it's oscillating, and we'll go to the next stage. With the transistor still in the transistor socket, I thought I would check with a scope around, and I detected right at from the volume control, right at this 10 microfarad coupling capacitor, and I saw audio on the oscilloscope. Here's what I'm seeing on the oscilloscope, it's definitely audio, because when I change the stations, it gets bigger and smaller depending on whether it's between stations or on stations. So I put the signal tracer on it. This is what I get.
With highs up to 12 degrees, nice and sunny as we get into both our Saturday and Sunday.
The radio is working very well up to that point, tuning nicely.
Showers. Rain starts to pick up for the afternoon and for Tuesday night, and then by
so
Wednesday,
very well.
60% chance
for
a shower.
Very well. So now I just have to worry about the driver and the push-pull stage. I removed the transistor socket and put the 2N3904 in the place as the autodyne transistor, and I just checked to see if it works, and I see audio there, so it is working. Next, I'm going to replace the driver transistor and see how that works. I looked at the specifications of the missing 2N1251 and one that I had on hand, a 2SD33, and they both are very similar. They're both NPN germanium transistors, and they both dissipate 150 milliwatts max. So I'll try the 2SD and I'll put it in and see what happens. One thing I always liked about these early Japanese transistors, that would be 1950s, 60s transistors, is that they had the same pin layout as the American standard, which was emitter-base collector. The later Japanese transistors always put the base off on the side, which I never liked. I always found that confusing. But anyway, we'll put this in and see what happens. Germanium transistors are much more susceptible to heat damage, so it's best to use some kind of heat sinking, whether it's locking forceps or a little clip-on heat sink like that one on the right. Okay, we've lucked out. I replaced that 2SB33 driver transistor, and I put a scope on the output, and there was audio coming out. So that means that the two push-pull transistors are fine. And so I hooked up the speaker, and everything seems to be working very well.
If they do the right things, it could be a really dangerous line for us.
So there we are. I just am now going to see about putting the speaker and everything back in the case, and we have a working radio. One tip I've learned over the years is that when you've soldered in a transistor or SCR or any other small component with leads, through leads, when you've soldered them at the bottom of the circuit board, grab the leads that you're going to clip off with a pair of pliers or locking forceps. That relieves the mechanical stress traveling up the lead. When you clip them, it causes a stress to move up the wire. So if you have a pair of pliers on there, that absorbs the mechanical stress and it doesn't travel up into the transistor, possibly cracking some very delicate crystal or wires that mount on the crystal. It's just a good thing to know. Here I've the radio is all in its case, and it's working very well with the new speaker. The only problem is that the 9-volt battery doesn't fit in it. The back won't fit on it if you have a 9-volt battery. This radio was originally meant to run on a 9-volt mercury battery, and I don't even know if you can get those anymore. But I think I'll come up with some kind of a little battery box that has 2 N cells, maybe 3 N cells of the type that you use in your key fob. They're 12 volts. And I'll put in a little circuit that brings it down to 9 volts. So that's the next thing I'm going to be working on.